Welcome! This is 7.1, nth roots and rational exponents. Our purpose in this section is to explore what roots are, to use some exponent properties, and also solve equations by using nth roots. So go ahead, pause the video, and really quickly try to solve the warm-up questions. Perform the indicated operation, and when you're done, hit unpause to check your answers. How'd you do? I want to look at number 2. So just quick reminder, if you have a plus or minus sign in the parentheses, you have to write it out twice and then FOIL it. You can only distribute the exponent if it's multiply or divide inside the parentheses. We're going to talk about that more as this year goes on. All right, square roots and other roots. The main question of this section is, what really is a square root, or what really is a cube root? So first of all, what does square root of 9 really mean? Well, what it really means is we're looking for what number squared would give us 9. So what number squared gives us 9? And the answer is 3. 3 squared gives us 9. Another way of thinking about it is a square root is looking for something multiplied together twice to get the number. Let's say I had a different type of root. This is called a cube root. This little number right here, that's called the index, and that tells us basically how many times I'm multiplying to get together a number to get the number underneath. So what could I multiply together 3 times in order to get 8 is basically what this is asking. And the answer is 2. 2 multiplied by itself 3 times gives us 8. Here's another one. This is the 4th root of 81. So this time the index is 4, and I'm looking for what number multiplied by itself 4 times would give us 81. And the answer is 3. Now, if you're trying to do this on your calculator, let's say I wanted to type in the 4th root of 81. Here's what I would do. In my calculator, I'm going to type the number 4. So I would go on my calculator and type in the number 4, and then I'm going to hit the math button. That is right underneath the alpha key on the left side of your calculator. And then if you look at this list that pops up, number 5 has something that looks like this. What's happening is the 4, the number you pressed earlier, is replacing the x. Now once you have that on your screen looks like this, and then go ahead and type in 81, and now when you hit enter, you should get 3. The next thing we want to talk about today is fraction exponents. So just a quick comment. We've talked about this in GO2, but if I have, for example, the square root of a times the square root of a, that is just equal to a. Now how does this translate to a fraction exponent? Let's say that a is really a to the first. Now the only way I can get a to the first is if I have 2 a's here, both with a fraction of 1/2 for their exponent, because 1/2 plus 1/2 is 1. So here's what I'm just showed you. The square root of a is a to the 1/2 actually. We can translate to that to other roots too. So the cube root of a is actually a to the 1/3 power. The 4th root of a is actually a to the 1/4 power. And you might not only have a number there. Well, let me give you the general term first. Here's the general term, a to the 1/n power. Okay, but let's suppose that I also have an exponent underneath with my m. The root number still goes on bottom, but this exponent now goes on top. So here's what I think about. Exponent goes on top, the root goes on bottom when I turn it into a fraction exponent. One more side note, and then we'll get to some problems. Notice that the cubed root of -8 is possible because if I multiply together -2 times -2 times -2, it is -8. But I cannot take the 4th root of -16, for example, because there's no number I can multiply together 4 times to get -16. It would be imaginary, actually. And we're not really talking about that in this class right now. So in our minds, we're going to think not possible for that. All right, let's talk about some real nth roots. So if I'm going to find the roots of something, it's really kind of like you're solving an equation. And let's say that I have this going on right here, the nth root of a. So let's say that n, that index, is odd. If that happens, there is one real nth root. So if n is odd, there's one real nth root. For example, the cubed root of 8 is just equal to 2. So this was what I was looking for, the index. All right, now if that index is even and the number underneath is greater than 0, there will be two real roots. For example, the square root of 16, the roots are positive or negative 4. There's one thing we're going to add in the middle here that wasn't on your original sheet. If n is even and a is equal to 0, then the root is 0. So here's what this means. This makes sense if I write this out. For example, no matter what, the fourth root of 0 is 0, the square root of 0 is 0. Any root of 0 is equal to 0. That's what that's saying. And then last but not least, if n is even and a is less than 0, that means that I've got a negative underneath the root. The radical, that is imaginary. All right, here's the first thing we're going to do with this. We're going to find the roots of a. They're going to give us some information here. We're using the nth root of a. Okay, example a. N is 3, a is negative 125. Here's what I'm finding. You can use your calculator. Because n is odd, I go to back to my notes. Okay, n is odd, that means there's one real root. Oh, and the root is negative 5. That's it. Part B. N is 4, a is 16. So here's what I'm thinking. My index is even, and a is greater than 0. So I'm thinking there's going to be two roots, and the fourth root of 16 is positive or negative 2. Hit pause and try C and D. Unpause when you are done. C, your answer should be negative 2, and D, your answer should be 4. For C, it's an odd root. There's just one root then. And for D, it's an odd index. And so I only have one root. For C, I meant to say that it's an odd index. Okay, this is 7.1 part 2. We're going to do some rational exponent properties, and the first one I already showed you. So the first rational exponent property is the fact that if I have a base, my exponent is a fraction m over n. The bottom number is the index number, and the top number is the exponent of the base. And now there's two ways to write this. You could say the nth root and then a to the m, or you could have the nth root of a with an exponent outside of it. That is equivalent. Another thing you should think about is that this means that I could think of it this way. It's like 1 over n times m. That might kind of help you out a little bit. So just a reminder from the other video, a to the 1 over n power is the nth root of a. And let me translate this to a negative exponent. So a to the negative m over n. We learned before negative exponent translates something to the bottom. We're going to review this more in section 7.2. And then same rules apply as before. So it's the nth root and then a to the m power. Here's how we're going to use this. Knowing some properties of fractional exponents, I can solve a statement like 9 to the 3/2 without using my calculator. And you are allowed to use a calculator for the test or quiz, but as much as possible, see if you can do it without. All right, I said earlier, the bottom number is our index number. When I have a 2, that's really a square root. It's just so common, they don't write the 2 usually, but really I've got the square root of 9 with that. Then the top number gives me my exponent. So my exponent of that whole statement is 3. And now what I'm thinking is, okay, square root of 9, I know that is 3. So really I'm trying to find what 3 cubed is, and 3 cubed is 27. That is my answer. Part B, 32 to the negative 2/5 power. So again, I'm thinking, okay, bottom number is my index number. Top number is my exponent. We'll deal with that negative in a minute. For now, the 5th root of 32 is 2. What a negative exponent does is it moves it to the bottom of the fraction. And again, we're going to talk about this more in section 7.2. But this becomes 1 over 2 squared, which is 1/4. Pause the video and try C and D. Here's what I'm getting. 4 to the 5th power, which is 1024, and then part D, (1 over 16). Just a few quick comments for you about calculator usage. Let's suppose that instead of doing it on your own, you are trying to use your calculator. Quick comment, you should know that 9 to the 3/2 power, to enter that into your calculator, we need to use that caret key. It's right underneath the clear button, and then the fraction, put it in parentheses. Otherwise your calculator won't know that you want the whole fraction to be part of the exponent. One more comment I want to make. In general, if you have an odd exponent for an exponential statement, you're going to have one answer for your problem. We're going to talk about these in a little bit. An odd exponent equals one answer. For example, let's say I had x cubed equals 27. Here's what I mean. There's only one thing that I could put in for x to make this a true statement. The only thing I could use is 3. So there's only one answer. See, if you did a -3, it would be -27, which is not equivalent. The other thing you should write down is that if I have an even exponent, it's kind of like saying it's an even index when I'm taking the roots, but an even exponent, there are 2 answers. For example, if I had x squared equals 9, I could either have 3 squared equals 9, or I could have -3 squared equals 9. And one more quick comment, you need to be careful in your calculator because -3 squared in parentheses is not the same thing as -3 squared without parentheses. It doesn't work. Try it if you want. Alright, example 3. We're going to use this fact about roots that we talked about just a little bit earlier to solve some equations. So, flashback again to geometry 2. What I want to do is get my x term by itself, and then I'm going to take some sort of root to get rid of the power. So in this situation, I am going to divide both sides by 2. I end up with x to the 4th equals 81. And now, in order to get rid of the power of 4, I need to 4th root both sides. And this is what I meant by when you're taking an even root, a 4th root, we're going to have 2 answers. So the roots are positive or -3. And that's my answers for x. One comment I want to make, this is true, so the same pattern holds. So like if I had an x cubed, take the cube root to get rid of it. If I had an x squared, take the square root to get rid of the x squared. And every time we're going to get the variable by itself before we root it. Now if I look at example B, this entire statement is considered the root, or sorry, I meant the variable. So this entire thing is considered the variable. So this is actually right away ready to be rooted. So right away I would take the cube root of both sides. And again, taking the cubed root cancels out the cubed. So now I have x minus 2 equals the cubed root of 10. What you want to think about right now is, do I have 2 answers here or 1 answer? And what I'm looking at again is the index number. So if it's odd, there's only 1 correct answer, not 2. I'm going to add 2 to both sides. And if I type that into my calculator, I actually get 4.15. And by the way, we're going to get approximate answers for some of these. If I wanted to give the exact answer, it would just look like this. So there's the exact answer. Here's the approximate answer. Whenever you need to round today, round to the nearest hundredth. That means 2 decimal places. I'd like you to pause the video and try C right now. Unpause when you're ready to check your answer. You should be getting x equals positive or negative 2. Here's how I did that. Divide by 5, take the 4th root, and because it's even, I've got 2 answers. I'm going to go through D because this one is a little bit more tricky, but again, we got to get the quote variable by itself before I can take a cube root. So in this situation, this whole thing, x minus 1 cubed, counts as the quote variable. So I'm going to use normal equation solving skills, which means you usually are doing order of operations backwards. So first I'm trying to add over that 12 to get rid of it. 116 plus 12 is 128. Now I'm going to divide by 4 on both sides. 128 divided by 4 is 32. And now I'm at the stage where my variable is by itself. And because it's a cube, I'm going to cube root both sides. I've got x minus 1 equals the cubed root of 32. And then I'm going to need to add 1 to both sides. So the cubed root of 32, and then I'm going to add 1, and I'm ending up with approximately 4.17. So that's our approximate answer. And I just typed into my calculator cubed root of 32 and then plus 1. Some calculators, depending on your model, you may, when you type this into your calculator, you may need to do a close parentheses after the 32, depending on your calculator type. All right, for this lesson, 7.1, we learned about how to find the roots, we learned about simplifying with a fractional exponent, and we learned about solving each equation by using the nth roots. Yay!